All right, so when talking about how electrons are arranged in an atom, there are several different ways we can do this. The very first one we're going to talk about is drawing an orbital diagram. Now, an orbital diagram is a diagram that represents the electrons in an atom and their arrangement. So there's this diagonal rule that we can use to help us determine the order in which these orbitals, these sublevels, will be filled. So we always start at the bottom. We always start at the lowest energy orbital that is possible. Right? And this is, like I said, this is called the diagonal rule because these sublevels are not filled in number order. They're filled in a diagonal pattern. So we're first going to fill the 1s. Then the 2s, then we loop back around, hit the 2p, the 3s, come back around, 3p, 4s, come back around, 3d, 4p, 5s, and so on and so forth. Now you can always recreate this on your tests or quizzes. I'm not going to give this to you, but you need to know it. But you can always just recreate it. All the S's line up, all the P's, all the D's, all the F's, and then everything's lined up horizontally by number. All right, so now this will allow us to draw orbital diagrams. So let's do some examples. So this first one, we have fluorine. Fluorine has an atomic number of 9, so it has 9 electrons. Right? So the very first orbital is the 1s. We label underneath with 1s. Now we use arrows to represent the electrons. We always start with an up arrow, and I do half arrows because chemists are lazy, and then a down arrow. An up arrow represents an electron that is spinning clockwise, while a down arrow represents an electron that is spinning counterclockwise. All right, so the next one after 1s is 2s. Well, an up arrow and a down arrow. So at this point, we've put in 4 electrons. We have to get to 9, so we need 5 more. After the 2s is the 2p. A p sublevel has 3 orbitals, so we draw 3 lines. Now, the common mistake here is that kids do up arrow, down arrow, up arrow, down arrow, up arrow, down arrow in their orbitals. But the rule is that when you have multiple orbitals in a sublevel, you need to spread your electrons out across that sublevel before you pair them up. All right? So we would go all up arrows, 1 in each orbital. Well, we need to put 2 more in, so let's go back to the first orbital, put a down arrow, and then a down arrow in the second orbital. And then that's it. That's the orbital diagram for fluorine. Let's look at chromium. Now, chromium has 24, or has an atomic number of 24, so there are 24 electrons. Always start at the lowest energy orbital, which is 1s. Up arrow, down arrow. It's very systematic. You get the hang of it. After 1s is 2s. Up arrow, down arrow. After 2s is 2p. After 2p is 3s. After 3s is 3p. At this point, I've put in 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons. I'm going to 24, so I need to put in 6 more. Now, just for argument's sake, say that I just gave you this this orbital diagram. You would count up the number of electrons. Oh, it's 18. The element that has an atomic number of 18 is argon. So you need to be able to go backwards. Like if I were to give you this orbital diagram, you should be able to tell me that that is argon. All right, after 3p is 4s. And then after 4s is 3d, which has 5 orbitals. Well, after the 4s we have 20 electrons. We need 4 more for chromium. So up, 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 up. Now, I will note on this, chromium special, this isn't actually what chromium does. Instead, see how we have one orbital here that doesn't have anything in it? What chromium does is it borrows from its s orbital, and it says, oh, instead of this electron here in the s orbital, let's put it in that last d orbital. So it's one of the special ones. You're not going to have to worry about this, but it is special. If you go on to take AP, you will have to worry about that. All right, let's do one more example where it's not special. That was my fault. I didn't mean to put a special one in. All right, gallium. Gallium has an atomic number of 31. So 31 electrons that we need to fill in. Well, let's start at 1s, up, down, 2s, up, down, 2p, up, 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 down, 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 3s, 3p, 4s. Right now I'm at 20 electrons, which would be calcium, by the way. After 4s is 3d, 5 orbitals. That's 30 electrons, so I just need one more. After 3d is 4p. 1 electron in the 4p. And that's the gist of orbital diagrams.